All right, so now we're going to turn to today's class. What we're going to do now is we're going to start with, we're going to continue on with statistical tools. Tools that we're going to use throughout this semester. So this is a big one today, displaying scores or groups of numbers using tables and graphs. This is something that we're going to use throughout the entire semester. So these are some fundamental skills that we want to make sure that we develop. So what we're going to look at today is we're going to introduce the idea of descriptive versus inferential statistics, so the two major branches of statistics. We're going to take a look at frequency distributions, a very important tool to help our human minds understand numbers. We're going to learn how to construct and read a frequency table, and then we're going to learn how to read histograms. And then I'll just mention a little bit about homework assignment number 2, the homework for chapter 1. All right, so this is all part of that building our foundations of skills. What we're doing today is not going to seem too statisticky, I guess if that's a word, but we are doing this in preparation and building our skills for the super cool stuff that we're going to be doing in the latter half of this semester. But just a reminder that it all builds on the skills that you are developing right now. And the more practice you put in now, the more straightforward the rest of the semester is going to be. So be sure that you are taking advantage of all the opportunities for practice, the study plan, the extra Excel sheets, the pre-test, post-test homework, all of those. Make sure that you are getting very automatic with these skills, because again, the more automatic it is now, the easier it's going to be to chain it all together to do the amazing things that stats can do, but it builds upon that automatic foundation. All right, so let's just set this up. Let's say with a hypothetical, let's say that you were interested in sports psychology. And this is actually one of the largest growing fields of psychology right now. And you wanted to know, what is the effect of participating in sports? What are the psychological effects of actually getting out there, getting exercise, and participating in an organized sport? And there is, again, evidence that, and this is from the APA, that this is one of the largest areas of demand in the future for psychology is actually in sports psychology. So let's say that you want to ask that question. What does participating in an organized sport do for you psychologically? What you're going to need at the beginning stages of this project is you're going to need to use descriptive statistics. And descriptive statistics, these are statistics, statistical skills, statistical procedures that you use in order to organize data, in order to summarize data. Basically, in order to take massive amounts of scores and boil them down to something that our human brains can understand. It's to take all of these scores that we have and reduce them to a format that makes sense to our human brains. We need to simplify this data somehow. So for example, if you were doing this project, let's say that you wanted to know the influence of exercise and participating in organized sports on self-esteem. Let's say that that was your question. What you would do is you would start asking people who participated in organized sports, like this child over here, you would ask them, how much do you participate in organized sports? And you would give them a test on depression. So you would do that for this player over here, and you would do that for this college player over here, and you would do it for this high school girl over here, and you would do it for this guy over here who's waiting on the sidelines in a house league. You would do it for subject after subject after subject after subject after subject. At some point, you might end up with something like 200 scores. You've interviewed 100 subjects, you got 100 scores on how much do they play in organized sports, you got 100 scores for depression. Those 100 scores to your human mind are not going to make any sense. There's just too much data to understand. So descriptive statistics is going to simplify that, and oftentimes it simplifies it by replacing all of these scores with often a single number. So we're going to see very early on how we use one, for example, representative number to stand in for an entire set of data. So that is the descriptive statistics side of things, where you summarize data into a format that your human brain, your human mind can understand. The other side of statistics, which we're going to do in the second half of this course, is inferential statistics. And inferential statistics is where the power of psychology comes from. It's where the ability of psychology to help people comes from, because inferential statistics is where are the techniques that you use to go from a sample of individuals and make generalizations about the population. So if you were doing this study and you found that people who participated in sports had lower amounts of depression, without inferential statistics, all that you could say is that for the 100 people that you surveyed in your study, for those people, and only those people, participation in sports lowered depression. That's what you could say, and that's where it ends. So all of the hundreds of thousands or millions of people in this, in the country who are suffering from depression, if they asked you, do you think they would benefit from participating in sports? Based on those 100 subjects that you ran, without inferential statistics, all you could say is, I don't know, maybe. I know what I found works for these 100, but I can't really say anything about anybody else. And that's where psychology would end. And imagine how useless psychology would be if that's all that we could do. The power of psychology comes from inferential statistics. The power of psychology comes from the fact that we can take a look at 100 scores and then make generalizations, intelligent generalizations, non-biased, objective generalizations about the entire population. So instead of just saying participation in sports lowers depression for these 100 people, we can say participation in sports lowers depression in general, so that people outside of our study can benefit from our psychological contribution. So that's what we're going to be doing. That's the ninja stuff that we're going to be working towards, that inferential statistics, but it's built upon this foundation of descriptive statistics. All right, so one of the first descriptive statistic techniques we're going to use is the idea of the frequency distribution. And what a frequency distribution is, we have a picture of one right here. It is a ordering of your data in a specific way. It's an ordered listing of how many individuals achieve a particular score. So in a variable that you're measuring, how many individuals achieved each score on that particular variable. You put it in order, that's a frequency distribution. So for example, we'll zoom in here. If I gave a test to a group of students and the test was out of 100, this would be a picture of a frequency distribution for that particular test. So in this case, we have all of the possible scores here on the x-axis, and each of these bars represents how many people achieved that particular score. So the first thing that we'll notice is that nobody scored 0 to 9. Nobody scored 10 to 19. Nobody scored 20 to 29. Nobody scored 30 to 39. Nobody scored 40 to 49. But then once we get to 50 to 59 out of 100, we find out that some people scored that amount. And specifically, we have 2 individuals that achieved that score. So it's the frequency of individuals that achieved a particular score. And the way I like to think about it is this is almost like an apartment building where people live, and their score is the address that they live at. So 2 people here live at a score of 50 to 59. We got 4 people who live in the apartment building, 5 people who live in the apartment building next to them with a score of 60 to 69. We got 4 people living at 70 to 79. We got another 5 people living 80 to 89. And then we got that one solitary individual living at 90 to 100. And that is a frequency distribution of the scores on this particular test. So again, this frequency distribution has taken a whole bunch of numbers, summarized them in a way that we can understand, and then once you are able to read a frequency distribution very fluently, you'll see that it summarizes a lot of information in a very useful way that's very readily understandable and very quickly understandable to our human minds. Any questions so far? All right, so these frequency distributions, they can be made or structured in two major ways. So one way is to have them in a table, and then the other way is to have them in a graph. So the graph we've just seen, and we'll see how to build that in just a little bit. The table we're going to take a look at right now. So frequency tables, let's consider the following example. Let's say that you got the following set of n equals 20 scores. So that n there, that stands for the number of scores. So oftentimes it's important to know just how many scores do you have in your raw scores. And n is what is used to indicate how many scores you have. So if you see n equals 20, that means that you have a set of 20 scores. There's 20 scores in total, and they're on a 10-point scale. So it was a 10-point quiz, and there are the scores right there. When you take a look at those scores, even though it's only 20, it's kind of hard to make sense of this particular set of scores. And it's kind of hard to answer questions about this particular set of scores. So for example, if I decided that anybody that scored 6 or lower on this 10-point quiz is going to have to come into an office hour for some extra tutoring, how many people can I expect to have in my office hour? What's the attendance that I can plan for? Taking a look at that score, that set of scores right there, very difficult to answer that question. So what we need to do is we need to construct a frequency table of these scores. We need to put it in an order, put it in a structure that our human minds can deal with. So this is what the frequency table has as its headings. The first one, it has a capital X. That's apparently standing for the scores. It does not stand for scores. I wrote it that way because that is the typical way that you're going to see it. But you're going to do yourselves a large favor, and whenever you see a frequency table and you see that X, all right, so if you see a frequency table that has the scores, you're going to read that as the possible scores. All right, so don't get in the habit of reading X as the scores when you encounter it in a frequency table. In a frequency table, it's special. It's the possible scores. And I'll show you why that is important in just a moment. So this is oftentimes read as a score. Read it as the possible scores. F over here is for the frequencies. Again, do not read it as F. Read it as the frequency. And what you would do is you would list all of your possible scores. So in this test, it is possible to get 10 out of 10. And in this quiz, it is possible to get 9 out of 10. And it's possible to get 8. And it's possible to get 7. And you can get 6. And you can get a 5. And at one point, these go automatically. You can get a 4, a 3. Oh, no, they don't. A 2 and a 1. And you can even get 0. You can get 0 out of 10. You can get everything incorrect. So what we do is we list the possible scores. And then we construct a frequency table by ordering these scores and getting the number for each of these possible scores. So for example, we'll zoom in on that just to get the ball rolling. What we would do is we would go through all 20 scores and we would count how many times does the score of 0 out of 10 occur. And if you go through here and you count how many times people got 0 out of 10, you'll find out that it has a frequency of 0, right? So 0 out of 10 never occurs. It has a frequency of 0. You would do the same for 1 out of 10. You would scan through the 20 scores. 1 out of 10 does not occur. It also has a frequency of 0. So this table has now told us that for a possible score of 0 out of 10, 0 people achieved it. For a possible score of 1 out of 10, 0 people achieved that. For a possible score of 2 out of 10, we will start analyzing our scores, and we have one individual right there scored 2 out of 10. We have a second individual right there scored 2 out of 10. So we have 2 people that scored 2 out of 10. So 2, a possible score of 2 has a frequency of 2. It occurred twice. Same thing we would do with a score of 3. There's one individual that scored 3 out of 10. There's another individual that scored 3 out of 10. A score of 3 out of 10 has a frequency of 2 as well. We will continue on with this for a score of 4. So that occurs twice as well. It has a frequency of 2. We would continue on with a score of 5. 5 has a frequency of 2. We would continue on with scores of 6. There's only one person that scored a 6 out of 10. It has a frequency of 1. We got 1, 2, 3, 4 people that scored 7 out of 10. It's got a frequency of 4. And then we got 1, 2, 3 individuals that scored 8 out of 10. And that's got a frequency of 3. We got one individual that scored 9 out of 10. So that has a frequency of 1. And then we got 1, 2, 3 individuals that scored 10 out of 10. So 10 out of 10 has a frequency of 3. So as you can see, once we have all these frequencies up here, they're much easier to deal with. So for example, one of the first things that we can do is we can check to make sure that we've done our frequency table correctly by checking how many scores do we have in our frequency table. So if we add up all of these frequencies right here, what number should we end up with for this situation? We should end up with 20, exactly. We were told there were 20 scores. We better have 20 scores in our frequency table. So if we add up all of the frequencies, we get a sum of 20, so we know we've created it correctly. So remember back last class, the summation formula in Excel, if you're making your frequency distributions in Excel, you can use that to double check to make sure that you've created them correctly. All right, other things that you can do with this is you can answer questions by that would be much more difficult to answer with just a random assortment of numbers like this. So for example, I mentioned before that if I was giving this test, I might decide that people that scored 6 out of 10 or lower need to attend a tutoring session in order to improve their skills. So in that case, I would want to plan how many people are going to come to this particular tutoring session. Well, looking over here, I'm basically asking how many people scored 6 out of 10 or lower, and that is not something that my human brain can easily do. Looking at it here, much easier to do. So we got one person that scored a 6, 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. There are 9 people that scored 6 or lower. I should expect 9 students to come to this extra tutorial session. If you are going to give out prizes to people that scored 9 out of 10 or higher, you know that you are going to need 1 prize plus 3 prizes, 4 prizes total, because 4 people scored 9 out of 10 or higher. So it's much easier to understand your data when it's in this format. It's in a format that our human brains can understand. All right, so one thing though that tricks our human brains, and I'm going to mention this right now, and this is why I want you to always read this as the possible scores. So one mistake that I have seen time and time again is when you're dealing with a frequency table and you have to interact with it and you have to get certain information from the frequency table, one of the classic, very common things that people ask for is the sum of the scores, right? So we just talked about this last time. You could be asked, what is the sum of the scores, right? Very common question. Given this frequency table right here, what are the sum of the scores? And this is where you need to make sure that you have a rock solid understanding of what it is that is being displayed here so that you don't fall for this error. Because I mentioned, read this column right here, not as the scores, but as the possible scores. Because the number one error that people make when they're asked for the sum of the scores and they're dealing with a frequency table is not understanding what that frequency table is giving them, and then simply saying, well, I'm looking for the sum of X, right? That's even worse. But I'm looking for the sum of the scores. Where can I find the scores? Well, here's something that says scores. So the sum of the scores is going to be 10 plus 9 plus 8 plus 7 plus 6 plus, and that is completely wrong. So the sum of the scores is not just summing down this column here, because these are the possible scores. They're not the scores that people actually achieve, right? Nobody got a score of 0. Nobody got a score of 1. Those are not the scores. Those are the possible scores. So make sure that you really understand, take the time to really kind of focus in on what a frequency table is actually showing you, so that when you see a question like, oh, what are the sum of the scores, you'll take a look at this frequency table and you'll say to yourself, all right, well, I remember that this column here, even though it's labeled X, which is the scores, in a frequency table, this is the possible scores. And we're not asking for the sum of the possible scores, we're asking for the sum of the scores. So what I need to do is I need to read this frequency table and say, all right, we got 3 scores of 10 out of 10. So we're going to want to go 10 plus 10 plus 10. And then what do we have? We got 1 score that's 9 out of 10. So then we go plus 9. And then what do we have? We got 3 scores that are 8 out of 10. So we go 8 plus 8 plus 8 plus, and then you do it for 7, 6, 5, all the way down until your last actual score. So this is the sum of the scores. So again, there's going to be pitfalls in statistics. It's straightforward once you get that understanding, but there's going to be these little possible tricks and little possible pitfalls along the way. I'll highlight as many of those as I can, but the rest is up to you. So when you're encountering a frequency table, again, read this as the possible scores, so that when you see a question asking you for the sum of the scores, and this happens all the time in stats, when you're reading off the table, you won't just sum that column right there, which is going to be a temptation. Fight against it, don't do it. You're going to unpack the table and recover the actual scores so that you can do the sum of these scores. All right, so that is my warning in terms of the sum of the scores. So we'll continue on. So that was a frequency table using frequencies. Sometimes you'll also see frequency tables using percents. So occasionally, especially once you get into the 1,000 subject limit, the numbers just get too big, the numbers just get too complicated, that you want to deal with percentages instead of actual raw frequencies. So you can convert this into percentages using this formula over here, where you have the frequency for each score divided by the number of scores multiplied by 100. That'll give you the percent. So if we apply that to this table here, we can see that 3 divided by 20, so we got 3 scores of 10 out of 10. We got 20 total scores multiplied by 100. That gives us a percent of 15. And using that formula, we can populate the rest of these with percentages. And you'll know that you've done that correctly if this adds up to 100, or depending upon rounding error, 99.9 or 100.1. Sometimes you'll get a little bit off if you round it too early. All right, so that's the frequency table. Any questions on that? All right. So the other form that it can be structured as is a graph. So we've already seen the graph. So let's take this frequency table here and we'll put it into a graph form. So the graph is usually called a histogram, and that's a graph that is a frequency distribution graph, and it looks like this. So this graph is made out of the table that we just created. So if we were to take this table and then put it into graphical form, that's what the numbers would look like. So there's the table for comparison. And as you can see, we have scores, once again on the bottom here. Once again, in a histogram and a frequency distribution, these are possible scores. So once again, if you see the sum of the scores and you're given this histogram, do not go, oh, let me see, there are the scores right there. 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus wrong. That's not the way to do it. Realize that these are the possible scores, and you have to unpack these bars here to find out what the real scores are. So once again, we got 3 people that scored a 10. We go 10 plus 10 plus 10. We got 1 person that scored a 9 plus 9. 3 people that scored an 8, 8 plus 8 plus 8, and then so on. You need to unpack that particular graph. But in this case, once again, in graphical form here, you can see that the height of each bar indicates the frequencies that these scores occurred at. And something like this can give you a very quick look at the data to figure out how are your scores, for example, distributed. So in this case, it is clear that a large portion of the students are doing rather well, but it's also clear that a large portion of the students are doing particularly, they're having a particular hard time, they're struggling. So it very quickly lets me know that there are these 2 distinct groups of students, that they're rather sizable. It's a rather large area for this histogram. And again, that's just something that you'll be able to do the more able you are to read a particular histogram. All right, so any questions on the graph, the histogram here? All right, so the last thing that I'll mention is that in stats, they distinguish between a histogram and what's known as a bar graph. So this is nitpicking. It's not going to come up in this semester, but it does come up from time to time in your readings, and it will come up in your sort of academic career as psychologists. So I just want to make sure that you know the difference. So this right here is a histogram, and a histogram does not have spaces between the bars, and that is used to indicate continuous data where you can get those in-between scores. A bar graph, on the other hand, has spaces between the bars, and this is to indicate scores that are discrete. So technically, if I had scores on a 10-point quiz, I should put them up as a bar graph, indicating that you can score a 2, or you can score a 3, but you cannot get 2.5. And you can score a 7, but you can't get 7.5. Right? So that's what's indicated here in the bar graph. Notice, though, that it gives you the exact same information. So the bars are exactly as high. It's built off of the same frequency distribution table. It's just that it's, and again, it's kind of like a nitpicky thing that you'll encounter in different areas. Question?
You said the first one was continuous data. What's the bar graph called?
Discontinuous data. Yep. Yeah, so continuous data, one of the easiest ones to, one of the easy examples for continuous data is height, right? They just gradually increase in height. So you can be 5'6", you can be 5'6 1/4", 5'6 1/2", 5'6 3/4. You can be in between there depending upon how finely you want to measure it. So if I was graphing heights and I wanted to make sure that technically nobody was going to argue with the way that I graphed this frequency distribution, I would put heights as the histogram. If I was grading scores on a 10-point quiz, it should technically be in a bar graph, but we're not going to make that distinction in this course, but just something that you should know for your future in psychology. All right, any final questions on anything that we covered today? All right, so that's the new stuff. So what we're going to do now is we're going to turn it over to practice time. But before we do, just a couple of announcements. First off, just make sure that you are aware of the MyStatLab study plan. It's the Quiz Me Points option. Make sure that as you're progressing through your study plan, you are earning mastery points. So the score that is going to be substituted for your pretest points is going to be your mastery points. So for example, I believe in chapter 1, there are 3 mastery points up for grabs. If you complete, and let's say that, you know, on the pretest you really struggled, let's say that you got 0% on the pretest. If you grab 1 mastery point out of the 3, then I will change your pretest grade to 33%. If you get 2 mastery points out of the 3, I will change your pretest points to 66%. If you get all 3, I will change your pretest points to 100%. So that's how the study plan mastery points work. Use it to supplement your pretest points. Use it just to gain extra familiarity and practice with the concepts that we're looking at. It's a great resource. And you can actually earn these mastery points as well through completing your pretest, through completing your homework. So it does track whether or not you're mastering these skills outside of the Quiz Me options, but the Quiz Me options are the direct way to earn those mastery points. And just one more time, be sure that you are getting familiar with how to use MyLab. Specifically, be sure that you know your due dates. So your due dates are in MyLab, your due dates are in the syllabus, they are in multiple areas. That is to make sure that you have ample opportunities to know when your due dates are. But again, it's your responsibility to stay on top of those so that you can earn the maximum points while you're learning statistics. All right, so that is all that I wanted to cover for today. So we got half an hour left for practice time. So this would be a good time to try some of the Excel sheets that we had last time on order of operations. Make sure that you got that down and working. You can start up on your homework assignment for chapter 1. Give that a go, test that out. Basically, if you have any issues or anything, feel free to call me over. But you know, if you had a hard 3-day weekend and you kind of all staxed out for the morning, feel free to call it an early day. But if you do stick around for practice, call me over and I'll be glad to help. Other than that, I'm done covering what I wanted for today.